Okay, welcome to video 12.3, Interpreting Variation of Data Using Standard Deviation. So our measures of central tendency give us numbers that describe the typical data value in a given data set, but they do not let us know how much variation there is in the data set. So two data sets can have the same mean, but look radically different depending on how spread out or varied the numbers are in the sets. As we've previously discussed, the interquartile range gives a good idea of the spread of data, but the best measure of variation within a data set is the standard deviation. This is also found using our calculator. So standard deviation, which is this SX in your calculator, tells us on average how far a data point is away from the mean of the data set. The larger the standard deviation, the more variation within the data set. The smaller the standard deviation, the less variation within the data set. So when using standard deviation, you will always need the mean. Okay, so let's see how we use and interpret the standard deviation. In this exercise, we're going to look at the farm with the baby chicks and how much they weighed after 1 week of growth, and we're going to find the mean, median, and standard deviation by going to our calculators again like we have already been doing. We're going to put all of our data into L1, so you do that by going to Stat, Edit, clear anything that's in your list by going up, clear, down, and then you can enter in the 2, 1, 3, and so on until you have that entire list in your L1. Then you're going to go ahead and find the mean, which is X bar, median, MED, in the calculator, and standard deviation, which is SX, for the data set, rounding to the nearest tenth. So when we go to our calculator and we look at the mean, median, and standard deviation, the mean is right at the top. The median we have to scroll down to find, and then the standard deviation, if you scroll down, you have to scroll back up to find that in the calculator. And then we get these values, 3.7, 3.5, and 1.8. So what I'm going to do first is represent this information as a dot plot, as we've already done and seen in the previous video. So I'm going to go ahead and label my X and put a title on the dot plot. So I can see here that I have all of my data represented as a dot plot, and I have a title and the numbers so that I know what everything represents. Now we have the bell curve to the right of that, and this is showing us that we can write the mean in the middle here. Then we would have a standard deviation tells us how much it deviates away from the mean. So in other words, most of the data will fall within this range here. So I would go up 1 standard deviation by taking 3.7 and adding the standard deviation, which is 1.8, to get the 5.5, and then subtract 1.8 from 3.7 to get 1.9. So that would show me that the data, a bulk of the data, falls between 1.9 and 5.5. But not all bell-shaped curves are symmetrical. They can be skewed with a tail, but we still use the mean and standard deviation to create the boundaries. And this will be explored more in Algebra 2 and AP Statistics. The next question says, how many data values fall above 1 standard deviation above the mean? So I'm looking for, if we have the 3.7 above 1 standard deviation above the mean, that would mean we need to add 1.8 to that 5.5. That's 1 standard deviation above the mean. So how many fall above 1 standard deviation? So if I look back, that means that we're looking for above 5.5. So greater than 5.5, that would be here. So that would be our 6, so 2, and then 8, 1. So 3 data values fall above the 1 standard deviation above the mean. And the next question says, what percent of the data falls within 1 standard deviation of the mean? Well, now within 1 standard deviation, that means they can either be in anywhere in this bell curve that we showed here. So anywhere here from 1.9 to 5.5 is going to be within 1 standard deviation. So basically we're looking for how many of the values fall between 1.9, which is really going to be really close to 2. So starting at 2, up to 5.5, so only up to 5. So how many fall between 2 and 5? So we just have to count the dots. 1, 2, 3, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 15 data values fall in that area, but the question asked for the percent of data values. So 15 out of the 20 is 0.75, meaning 75% of the data values. Okay, that's it for this video. See you tomorrow.
Our next question says, a marketing company is trying to determine how much diversity there is in age of people who drink different soft drinks. They take a sample of people and ask them which soda they prefer for the two sodas. The age of those people who preferred them is given below. So we have two different sets of data here, soda A, and then they list out the ages in soda B. We want to figure out which soda appears to have a greater diversity in the age of people who prefer it. How did you decide on this? So the first thing we need to do is think to ourselves, what would give us the diversity? So pause and think for a second, what could we try to do? Well, to start off, we're going to try by finding the range for each soda. So for soda A, when we look through the data, I see that the maximum age is 44 and the minimum is 16. So we're going to put 44 minus the 16. And when we do that, we get our range. So soda A has a range of 28. Now we need to do the same thing for soda B. So the maximum for soda B was 30 and the minimum was 18, leaving us with the answer of 12. So when I look at those two ranges, 28 and 12, I can see soda A had a greater diversity based on the data range. Now for part C, I want you to pause the video and you're going to type in all of the data for soda A in L1. This is very important that you pause the video and try it on your own to make sure that you can calculate the mean and the standard deviation. So pause the video, enter in all of the soda A information that we have in the first one in L1. Now think to yourself, do we have a frequency list? We do not have a frequency list because this is just a soda A and a soda B, two different sets of data here. There is no frequency showing that it's happening more than once. So in L1, type in all of the purple that I highlighted, soda A data, and then you're going to, so to type that in, you're going to go to Stat, Edit. If there's anything in there, you're going to go up, clear down, and then you're going to enter in all of that data. After the data is entered in, go to Stat, over to Calc, and then one var stats. That's where you'll find the X with a bar showing the mean and the S sub X showing the standard deviation. Do that for soda A and soda B. Okay, and then it said that we needed to round our answers to the nearest tenth, so hopefully you rounded to the nearest tenth, and we found our answer of 26 and 7/10, 9 and 1/10 for soda A, and then 23 and 4/10, and 4 and 1/10 for soda B. Based on this, which data set has more variation, and explain why in the context with the standard deviation. So if I look at the standard deviation, I can see that 9.1 is bigger than the 4.1, so that means soda A shows more variation in the data. So you may need to pause that to write it down. Soda A shows more variation because the larger standard deviation shows more variation. Part D says how many people fell within one standard deviation of the mean for soda A. How about for soda B? So the question is, how can we do this to find how many fell within a standard deviation? Well, to do that, we start with the mean, the 26 and 7/10 in the first one, and we're going to add and subtract the standard deviation to figure out how many are up one standard deviation and down one standard deviation from our mean. So go ahead and do that in your calculator. So when we do that, we find that up 1 would be 35.8 and down 1 would be 17.6. So what we're looking for is how many are between 17 and 6/10 and 35 and 8/10. So what you want to do is you want to go through the list in soda A and try to find how many fall between those two numbers. I would suggest highlighting them so that you know that they do fall, or I had other students cross out the ones that do not fall. Either way, I like to highlight so that I'm not eliminating any of my data. So how many fell? Pause and count to see if you get the same number that I do. I ended up with 9 people. Okay, now we're going to do the same thing with soda B. Again, pause the video and try to do the same thing for soda B to see if you get the same information that I do. So hopefully you had the 23 and 4 tenths plus 4 and 1 tenth and 23 and 4 tenths minus 4 and 1 tenth to give you 27 and 5 tenths and 19 and 3 tenths. So we're looking to see how many are between 19 and 3 tenths and 27 and 5 tenths. Go ahead and go through the list again to figure out how many fall in that between 19 and 3 tenths and 27 and 5 tenths. Again, you can highlight the ones that fall in that range. And I found 8 people. Okay, exercise 3. Which of the following data sets would have a standard deviation closest to 0, and explain how you arrived at your answer without using your calculator? So we need to think to ourselves, well, if it had a standard deviation that was actually 0, that would mean that the data had no variation. Can you think of a data set that might have no variation? What would that mean? What would that look like? Pause and think that through. What it would mean is that there is the same number in our data set. So if we're looking for one that's closest to 0, because not necessarily 0, we're looking for the one with the least variation in it. So look at the data and try to answer the question, then pause to see what I got. I ended up with choice 3 because looking at the data, there is the least variation in choice 3. All right, thank you for watching this video, and we'll see you in class.